So welcome again. So we continue with examples on solving second order linear homogeneous differential equations. So first one, verify that y1 e raised power 4x and y2 e raised power 2x satisfy this equation, and then write down the general equation, a solution of this equation. Now, to prove that y1 is a solution to this equation, we simply differentiate y1 twice and then replace into the differential equation to see whether left-hand side is equals to 0. So for y1, implies dy1 dx is given by 4 e raised power 4x, and second derivative of y1 with respect to x will be 16 e raised power 4x. Now, if y1 equals to e raised power 4x is a solution, then d squared y1 dx squared minus 6 dy1 dx plus 8y1 equals to 0, i.e. 16 e raised power 4x minus 6 into 4 e raised power 4x plus 8 e raised power 4x will be equals to 16 e raised power 4x minus 24 e raised power 4x plus 8 e raised power 4x, which is the same as 16 minus 24 plus 8 e raised power 4x. Now, this is clearly 16 plus 8 minus 24, which is 24 minus 24. And it's not hard to see that this is 0 times e raised power 4x, which is just 0. So y1 is indeed a solution. Now, similarly, if y2 is given by e raised power 2x, then dy2 dx is 2 e raised power 2x, and d squared y2 dx squared is 4 e raised power 2x. Substituting, we have 4 e raised power 2x minus 6 2 e raised power 2x plus 8 e raised power 2x, which is the same as 4 e raised power 2x minus 12 e raised power 2x plus 8 e raised power 2x, which is 4 minus 12 plus 8 e raised power 2x, which is the same as 4 plus 8 minus 12 e raised power 2x, which is 12 minus 12 e raised power 2x, which is 0 times e raised power 2x, and this is equals to 0, which is the same as right-hand side. So that y2 equals to e raised power 2x is also a solution of the given equation. Now, the final solution. Now, since the Wronskian of e raised power 2x, e raised power 4x is given by, so 2x, e raised power 2x, e raised power 4x. Derivative of this is 2 e raised power 2x. This one is 4 e raised power 4x. Be given by 4 e raised power 4x times e raised power 2x minus 2 e raised power 2x times e raised power 4x, which is 4 e raised power 6x minus 2 e raised power 6x, which is equals to 2 e raised power 6x, and this is a non-zero value. Then e raised power 2x and e raised power 4x are linearly independent functions. So which means, which also satisfies the given differential equation. So this implies that y1, which is e raised power 4x, and y2, which is e raised power 2x, are solutions. And the general solution is simply a linear combination of these two. So y given by c1 y1 plus c2 y2, i.e. y equals to c1 e raised power 4x plus c2 e raised power 2x is the general solution of the given equation. Example 2, find values of alpha so that y equals to e raised power alpha x is a solution of this differential equation. Hence, state the general solution. Now, if we have been given y equals to I raised to alpha x is a solution, then that means that if we get the derivatives of this y and replace into the differential equation, then it is satisfied. So given y equals to e raised to alpha is a solution, then dy dx is alpha e raised to alpha x, and this is like the trial solution, alpha squared e raised to alpha x. So when you replace these values into the differential equation, then it should be satisfied. So using these values in the given equation, we get alpha squared e raised to alpha x, and then minus alpha e raised to alpha x minus 6 e raised to alpha x equals to 0, i.e. alpha squared minus alpha minus 6 e raised to alpha x equals to 0. Now, this implies alpha squared minus alpha minus 6 equals to 0, since the exponential part can never be 0. Now, with this quadratic in alpha, product is minus 6, sum minus 1, numbers minus 3 and 2. So we'll have alpha squared minus 3 alpha plus 2 alpha minus 6 equals to 0. Now this pairs alpha into alpha minus 3 plus 2 into alpha minus 3 will give us 0. So which means alpha minus 3, alpha plus 2 are the factors of the quadratic equation. So this means alpha equals to 3 or alpha equals to negative 2. So those are the two values of the differential equation. So therefore, y1 of x is e raised power 3x, and y2 of x is e raised power minus 2x. Now, the general solution is a linear combination of these two, c1y1 plus c2y2, i.e. y of x is c1 e raised power 3x plus c2 e raised power minus 2x. So therefore, this is the general solution of the given differential equation. Example C or 3, solve the equation y double prime plus y prime minus 6y equals to 0. So solution, let y equals to e raised power rx is the solution. So this means y prime is r e raised power rx and y double prime is r squared e raised power rx. So using these values, we get r squared e raised power rx plus r e raised power rx minus 6 e raised power rx equals to 0. So r squared plus r minus 6 e raised power rx is 0. So auxiliary equation is r squared plus r minus 6 equals to 0, since exponential can never be 0. So product minus 6, sum 1, numbers minus 2 and 3. So the quadratic will be r squared minus 2r plus 3r minus 6 equals to 0. So r into r minus 2 plus 3 into r minus 2 equals to 0. So r minus 2, r plus 3 equals to 0. So r equals to 2 or r equals to minus 3. Now this tells us that y1 is e raised power 2x and y2 is e raised power minus 3x. So therefore the general solution is y of x is c1 e raised power 2x plus c2 e raised power minus 3x. Since we know that it's usually given by y equals to c1 y1 plus c2 y2. Thank you.